Hi students, in this part we will discuss about the topic power of accommodation from the chapter The Human Eye and the Colorful World. So the topic here is the power of accommodation. Now, what is power of accommodation? This is the spatial ability of eye lens to adjust its focal length. We know that eye lens is flexible. The spatial ability of eye lens to adjust its focal length to see distant as well as nearby objects clearly. Okay? By adjusting the focal length, you know that the curvature is not fixed. In this situation, the lens is thin and we are able to see distant objects clearly. In this situation, the lens is thick and we are able to see near objects clearly. So, this spatial ability is called power of accommodation. Now, we'll try to understand the sequence of events that happen during far vision and during near vision. So, for far vision, what happens? The ciliary muscles, for far vision, the ciliary muscles get relaxed. The ciliary muscles get relaxed and the eye lens becomes thin for far vision. So now the muscles here in which state? Relaxed state, and the lens becomes thin. As I have already discussed in part 1, the lens becomes thin. When lens becomes thin, its curvature decreases. So the curvature is decreasing. When curvature decreases, focal length increases. The focal length is increasing here, and because of that, power of the lens decreases. Power decreases. We are discussing about converging power. The converging power decreases, and it helps in far vision. Then for near vision, the lens becomes thick. The lens becomes thick because the ciliary muscles get contracted. The lens becomes thick. When lens becomes thick, its curvature increases. लेंस थिक होने से कर्वेचर इंक्रीज हो गया, एंड एज कर्वेचर इंक्रीजेस फोकल लेंथ डिक्रीजेस. As focal length decreases, power increases, and here converging power increases, and it helps in near vision. So the eye lens is having spatial ability to adjust its focal length to see nearby objects as well as distant objects clearly, and this spatial ability is power of accommodation. When we are looking at far point, the far point for our eye is considered to be infinity. Now, what is far point? Far point is the maximum distance to which we can see clearly. The maximum distance up to which we can see clearly with our eye is called what? Far point. And the closest distance up to which we can see clearly is called the near point. For normal eye, the far point is infinity, and for normal eye, the near point is 25 centimeter. So we can see from infinity up to 25 centimeter. This is our range of vision. When we are observing the far point, that is object at infinity, our muscles, ciliary muscles are in relaxed. When we are observing object at infinity, that is far point, our ciliary muscles or ciliary muscles of the eye are in relaxed state. At this position, the eye is said to be unaccommodated. And when we are observing objects placed at near point, that is 25 centimeter, the ciliary muscles get contracted. Ciliary muscles get contracted, and the eye and the lens at this state is said to be accommodated. So we can see clearly from infinity up to 25 centimeter. And 25 centimeter is also called the least distance of distinct vision. Also called what? Least distance of distinct vision, denoted by symbol D, and its value is 25 centimeter. So जब पर्सन का एज ज़्यादा होता है, जब एज ज़्यादा होता है तो सिलियरी मसल्स का फ्लेक्सिबिलिटी, लेंस का फ्लेक्सिबिलिटी, एबिलिटी ऑफ सिलियरी मसल्स, ये सब वीक होने लग जाता है. And what happens? The person is not able to see distant as well as nearby objects clearly, क्योंकि लेंस और आई ठीक से accommodate नहीं कर पाती है. And thereby we are not able to see distant as well as nearby objects clearly with the increase in age, or in the old age we can say. तो जैसे जैसे ऑब्जेक्ट हम लोग दूर से पास लेके आते हैं, 25 सेंटीमीटर के बाद there is what? The image of that object appears to be blurred. The reason is that 25 सेंटीमीटर के पास हम लोग का आई लेंस फोकल लेंथ को और कम नहीं कर सकता, and thereby the objects placed very close to the eye appears to be blurred. So we have discussed all that sequence of events that occur during power of accommodation. Now we'll discuss that how the power of accommodation of normal eyes plus minus 4 diopter. मतलब आई लेंस का पावर जब फार विजन के लिए है तो कितना होगा, नियर विजन के लिए कितना होगा, और एडजस्टमेंट कितना होगा, दैट वी आर गोइंग टू डिस्कस. सो फार पॉइंट इज इंफिनिटी. सो ऑब्जेक्ट यहाँ पे वी कैन कंसीडर एट इंफिनिटी और 1/0. इमेज कहाँ पे फॉर्म हो रहा है? रेटिना में. तो इमेज डिस्टेंस कैन बी कंसीडर्ड एज 2.5 सेंटीमीटर. वैसे डायमीटर इज 2.3 सेंटीमीटर, लेकिन न्यूमेरिकल्स में ये डायमीटर को लिया जाता है अराउंड 2.5 सेंटीमीटर. और जब नियर पॉइंट का कैलकुलेशन होगा तो ऑब्जेक्ट डिस्टेंस -25 सेंटीमीटर हम लोग लेंगे. इमेज डिस्टेंस विल बी द सेम 2.5 सेंटीमीटर. So we'll calculate power of eye lens in this situation, power of eye lens in this situation for far vision as well as near vision. So first I am doing calculation for far vision. Far vision. जब हम लोग दूर का चीज देखेंगे infinity में, u is taken as infinity or 1/0, then v, I already told v is 2.5 centimeter. And if you know u and v, you can calculate f, and by that f you can calculate power. So u और v से हम लोग f calculate करेंगे. We know the lens formula. Lens formula क्या है? 1/v minus 1/u equals to 1/f, or we can write 1/f is equals to 1/v, that is 2.5 centimeter, minus 1/u, that is 1 by 0. So 1 by f is equals to 1 by 2.5 minus 0 by 1, that is 0. So 1 by f is equals to 1 by 2.5 centimeter. Therefore focal length is 2.5 centimeter. So जब हम लोग दूर के ऑब्जेक्ट देखते हैं, ऑब्जेक्ट एट इंफिनिटी, आई लेंस का फोकल लेंथ हो जाता है 2.5 सेंटीमीटर, और इस फोकल लेंथ से वी कैन इजीली कैलकुलेट पावर P इक्वल्स टू 1 बाई f in meters, or it is 100 by f in centimeters. So here 100 by 2.5 centimeters, 100 by 2.5 centimeters, so you will get 40, the power is plus 40 diopter. So when we are looking at object at infinity, the power of eye lens becomes 40 diopter plus 40 diopter. Now for near vision, near vision मतलब ऑब्जेक्ट कहाँ पे है? ऑब्जेक्ट is placed at a distance of 25 centimeter from the eye, so u will be minus 25 centimeter. Object distance हम लोग लेंगे minus 25 centimeter. Image distance will be the same, that is 2.5 centimeter. And now we'll calculate focal length. We know the formula, 1 by f is equals to 1 by v minus 1 by u. So 1 by f is equals to 1 by v, 1 by 2.5 centimeter minus 1 by u minus 25 centimeter. Minus 25 centimeter. So 1 by f is equals to, we can write 10 by 25 plus 1 by 25. Now it is 1 by f is equals to 11 by 25, or we can write f equals to 25 by 11 centimeter. So we have calculated the focal length, कितना आ रहा है? 25 by 11 centimeter, and from that we can calculate power. P equals to 1 by f in meters. The formula is P equals to 1 by f in meters. So P equals to 100 by f in centimeters. Okay. So focal length is given here 100 by, focal length कितना है? 25 by 11, 25 by 11 centimeter. So it will be P equals to 11 into 100 by 25, 11 into 100 by 25 diopter we can write, and we will get power as plus 44 diopter. तो जब हम लोग पास का चीज देखेंगे जो 25 सेंटीमीटर डिस्टेंस पे है, दैट इज लीस्ट डिस्टेंस ऑफ डिस्टिंक्ट विजन, इन दैट केस आई लेंस का पावर हो जाता है प्लस 44 डायोप्टर, मतलब पावर इंक्रीज हो गया, कन्वर्जिंग पावर, और यहाँ पे पावर कितना आ रहा है? प्लस 40 डायोप्टर. तो हम लोग का आई लेंस जब इन्फिनिटी से लेके नियर बाई ऑब्जेक्ट्स तक देखेगा तो पावर का वेरिएशन कितना होगा? प्लस 40 से प्लस 44 डायोप्टर, और जब नियर पॉइंट से वापस फार पॉइंट को देखेगा तो पावर का वेरिएशन होगा प्लस 44 से प्लस 40. सो इंक्रीज या डिक्रीज कितना हो रहा है? इंक्रीज या डिक्रीज हो रहा है 4 डायोप्टर, एंड देयर बाय वी कैन राइट पावर ऑफ एकोमोडेशन ऑफ नॉर्मल आई इज प्लस माइनस 4d. So I think you have understood this calculation, and this calculation establishes that power of accommodation of normal eye for human being is plus minus 4 diopter. Now our topic is persistence of vision. Persistence of vision. Whenever we see any object in front of our eyes, the image is formed on the retina, and the sensation of the image remains on the retina for 1/16th of a second. इसका मतलब यह है कि ऑब्जेक्ट को आईज के सामने से रिमूव करने के बाद भी, हटाने के बाद भी, इस ऑब्जेक्ट से जो इमेज फॉर्म हुआ रेटिना में उसका सेंसेशन रहेगा 1/16th of a second. Okay, so I will show you one simple activity that will help you to understand persistence of vision, and its value is 1/16th of a second for normal human eye. So here in this board, one side there is a bird and other side there is a cage. And because of persistence of vision, what happens when you see the bird, its image, its sensation of the image remains on the retina for 1/16th of a second. But within that time limit, if I show you the cage and again the bird and again the cage, what will happen? It appears to you that bird is inside the cage. Now you can see that this side is the bird and the other side is the cage, and because of the persistence of vision, what happens? Look at here. The bird appears inside the cage.